In this section, we are looking at percentages. In the warm-up problems, you already found the percents of a few numbers, so let's take a look at some more. A toy store manager received a large order of Mr. Slincums just in time for the holidays. The manager places 20% of them on the shelves, leaving the other 120 Mr. Slincums in storage. How many Mr. Slincums were in this order? So we know that 20% of them went on the shelves, which means that 120 Mr. Slincums must represent 0.8 or 80% of all the Mr. Slincums that were ordered. So you can set up a proportion or an equation depending on which way you like to solve this problem. So if you want to use a proportion, you might want to set it up as 80% of the total 100% is equal to 120 out of x. And when you cross multiply and solve this problem, we're going to get 80x equals 1, 2, and 3 zeros, so 12,000. And then I'm going to divide both sides by 80. And we get 1,200 divided by 8. Let's see, that's the same as 600 divided by 4, or 300 divided by 2, or 150. So there are 150 Slincums in this order entirely. Edward is one of the 6 people who are each writing 180 math problems. When he solves every problem, he gets an incorrect answer for 10% of the problems that he wrote, and for 5% of the problems written by others. For what fractions of the problems does Edward get the wrong answer? Express your answer as a common fraction. So we need to know how many he got wrong and how many he solved. How many he solved is a little bit easier in this case. And that's because we know that Edward is one of 6 people and they are each writing 180 problems. So 180 times 6 gives us a total of 1,080 problems. So that's going to be our denominator for now, 1,080. I'm hoping to reduce this number a little later, but we'll see. Now we need to know how many he got wrong. So he got an incorrect answer for 10% of the ones that he wrote. So 10% of 180, which is 18. And for each of the 5 other people's problems, he got them wrong 5% of the time, so 0.5, or half of the other number we got. So if I already knew that 10% of 180 is 18, 5% of 180 is going to be only 9, half of that. And 5 times 9 is 45. So how many problems did he get wrong altogether? 18 and 45 makes 63. So my final answer that I need to reduce is 63 over 1,080. I can tell pretty quickly both of these numbers are divisible by 9, and so when I divide each of them by 9, I get 7 over 120, which is as much as that fraction reduces, so that is my final answer. The length of a rectangle is twice its width. If the length is decreased by 20% and the width is decreased by 20%, by what percent is the area decreased? So we know that the area of a rectangle is made up by doing length times width, and in this case, the length is twice the width, so the area is 2w times w. The length is decreased by 20%, which means that it is going to be actually having just 80% of what it had started as. So I've decreased it by 20%, now it is only at 80% of what it had been, and the width is increased by 20%, which means we are going to multiply that by 1.2, 100% and 20%. Now when I multiply these numbers together, it's really important to notice that the original area was 2w times w, and I still have a 2w times w in here. So in terms of what actually changed, what percent of the area increased or decreased, I'm really only multiplying these two numbers. Which makes me curious, and you should think about, does the length of the rectangle being twice the width matter in this problem? Does it actually change our answer? But for now, let's get our answer. Multiply 1.2 times 0.8 and move my decimal to the correct spot, 96. So 96%. What that means is this area is 96% of what the area was originally, because I am taking the same thing, 2w times w, and I'm multiplying it by 0.96. So by what percent did it decrease? Well, that would be 4%. 100% minus 96% is a 4% decrease. So if you have any extra time, think about, does the length of the rectangle being twice the width matter in this problem? What if it was 3 times the width? Would the area still have decreased by 4%, or would it have been a different number? Things to think about.